Hello, boys and girls. On my desk right now is a new TRX4m build based on the MEUS Ripper chassis. I picked this chassis because I want an Ultra 4 4400 class race truck. The end result is unlikely to crawl well, but this time I'm looking for something that goes fast with a bit more wheel speed, something close to a basher. The TRX4m platform is perfect for that application because not only you can choose the desired gearing in the axles, there are also multiple gear sets for the transmission to get you the top speed and acceleration you want for the truck. Another reason TRX4m is great as a base for fast trucks is because of the big M2.5 hardware it uses compared to the M1.4 on the Axial SCX24. These larger screws are much stronger and they can take more abuse. And also this MEUS chassis is made of flexible nylon. It's the best material for a basher build because of its high tensile strength. It is capable of being flexed and bent without breaking. As you can see, I'm fairly far ahead with its assembly. The kit comes with an instruction manual. It's pretty easy to put it together. I will just show you the things I'm doing to the truck that aren't in the manual. This chassis has been out for quite some time. There are many builds on the internet already. So I've done a few things to make mine a little bit different. The first thing you might have noticed already is the twin shock trailing arm suspension setup I got in the rear. The trailing arms are also made by MEUS. The kit is originally designed to work with the stock Traxxas chassis rails, but it can easily be adapted to the Ripper. These trailing arms are mounted like outboard links. They're not meant to be installed on the transmission skid. They are meant to be installed on this carbon fiber mounting plate. The mounting plate is then attached to the outside of the stock chassis rails. But for the Ripper chassis, all you gotta do is to sandwich the plates between the transmission skid and the chassis. The chassis is made of a flexible material, so it's no problem spacing it out. It's not going to affect the rest of the chassis. One problem though is the arms are not long enough for this chassis. In its original length, this has been extended with this spacer, but in its original length, the shocks would be tilting towards the center of the vehicle. That is ugly. To get the shocks mounted straight up and down like this, you just need to extend the arms using this spacer. MEUS supply these spacers in the kit to actually space out the shocks, but I don't find that I need to space out the shocks that much on this chassis, so I'm just using some Injora spacers. Injora sells a kit of spacers in different lengths. It's a very nice kit to get for custom builds. So once the trailing arms are spaced out, it allows you to have the shocks mounted straight up and down. It does extend your wheelbase a bit, so you'd have to use high trail length drive shafts. Anyway, that's pretty much it with how to fit the trailing arms and double shocks on the rear of the Ripper. While we're down here, you can see my axles are the MEUS isokinetic axles. I use them on all of my builds these days, both TRX4m and SCX24. Some viewers may remember I used these wheels on my Suzuki Jimny build video. I've since put on some nicer trio wheels on the Jimny, so these wheels are now here. I think they'll fit this truck more. Ultra 4 race trucks always carry a spare wheel on the back. So here is a spare wheel carrier. It's a part made by CChand for the Capo Cup 1, which is a 1/18th scale Land Rover Defender pickup truck. I have another one here. It's a very nice part and it fits perfectly on the back of the Ripper. For the actual spare wheel, I removed the rubber of one SCX24 stock wheel, of a SCX24 Bronco, more precisely. It's plastic, so it's lightweight. And also, I think it more closely resembles these aluminum wheels. For the transmission, I've taken the gears out of my TRX4m Rock Bouncer. This is it. I have a built video of it. I'll include a link in the description. I had 71% transmission overdrive gears paired to 9% overdrive gears in the front and rear axles. That combination was way too fast and too difficult to control when running a 370 sized brushed motor. And that caused me to shatter this 3D printed cage a couple of times. So I put stock gears in it now to make it more manageable. It's still fast, but much easier to handle. Those high-speed overdrive gears are now in the Ripper. I want the Ripper to be fast enough for jumps, to catch some air and make use of the twin shocks in the back. I think 71% overdrive gears in the transmission and 9% overdrive gears in the axles is the fastest combination available for the TRX4m. Actually, is it? Let me know in the comments if there are any faster gear selections. Moving on to what will be on top of the transmission. Here is another thing I am doing to make my Ripper more special, is having a FPV system. Not just a fixed camera FPV system. The camera is mounted on a tiny servo. This is actually the stock steering servo from a Axial SCX24. I am glad I kept this piece of crap servo and didn't just chuck it in the trash. I had installed a FPV camera in a SCX24 before, and I realized not being able to have the camera pan as you turn the vehicle is a huge limitation to visibility. So since the TRX4m is bigger, it gives me more room to try out this idea. And rather than using a complex transmitter channel mixing function or an expensive pair of goggles with head tracking to control the camera servo, I'm just going to have it turn as I turn the front wheels of the truck. However, I am using this servo controller to slow down the camera servo a little. This board also allows me to, aside from adjusting the speed of the servo, it also allows me to trim and adjust the endpoints of the camera servo independent to the actual steering servo of the truck by turning these dials. So from the steering channel of the receiver, I connected a Y splitter. And the splitter, one end goes to the actual steering servo, and the other end goes to the servo board, and then to the camera servo. And to power the camera and its video transmitter, I have here another Y splitter off of channel 3. One end connects to either the headlights or the light bar, and the other end feeds power to the camera. I will be connecting a switch in between so I can turn the camera off when I don't need it to save battery. And speaking of the battery, here is a 900 milliamp hour 2S LiPo battery. It will be sitting on an Injora battery shelf, and it should fit perfectly on the bottom of the camera servo, and all in the center of the truck. I will have all the electronics fit in this area somehow, and the ESC is right here. It is just a generic AM32 board. I can't have any bulky ESC here. It is really tight on space. I wrapped it in black heat shrink. I also wrapped both light control boards in black heat shrink. Here's the other one. The kit comes with two light control boards, one for the headlights and the other one for the A-pillar light bar. I put together a couple of switches, and I'll be putting them on the back of the truck using double-sided tape, I think. One turns on the ESC and the other turns on the FPV camera system. I want to be able to turn the camera and its image transmitter off when I want to just drive without FPV because it is fairly power hungry. Okay, so let's start stuffing all these parts into the truck. So I've decided to add this little receiver bypass harness for the steering servo. It allows the servo to get power directly from the battery. The ESC board has a built-in BEC of 5 volts, which is good because that's about the maximum the FPV system can accept. But I'm using a Little Guy Racing Parts Tremor servo. It's a high-performance servo that can take up to 8.4 volts. So powering the servo through this receiver bypass harness will supply the servo higher voltage directly from the battery. And obviously, the higher voltage would allow it to perform better. The downside is having to disconnect this white plug when turning off the truck. But my main concern is there are so many things drawing power on this rig. The steering servo, the camera, the image transmitter, the camera servo, the camera servo control board, headlights, LED light bar, and of course the motor itself. So my thinking is having a separate circuit for the steering servo can only be beneficial. You can get this bypass harness from RampCrab. It comes with every RampCrab servo. It has 3 ends. One connects to the steering servo, and from the servo it splits off into two. One is for steering signal, so it goes to the receiver. The other goes to the balance plug of the battery to give the servo power. Well, something else I want to point out, I don't know if anyone noticed, is this right here. This is actually a washer sandwiched in between the transmission housing. I don't know if anyone else has experienced this, but the 71% overdrive transmission gears from Injora must not be machined properly because they'd seize up completely when the transmission housing is tightened down, as if one of the gear shafts is too long. Therefore, I found I needed to space out the transmission housing a bit to free up that shaft. I've tried these overdrive gears in other transmission housing, same thing. It's these gears, because when I have other gears in there, there's no problem. Injora's quality is iffy sometimes. They are good for the most part, but sometimes I get things that are obviously made incorrectly. All right, moving on. With this chassis kit, you get a choice of Toyota FJ front fascia or Jeep Wrangler. You don't just get the radiator grille, you also get different hoods. I've chosen the Jeep because I want to paint the truck the Jurassic Park livery. Here are the finished body panels. True fans of the Jurassic Park movie would know why the number 18. I got the Jurassic Park stickers on Etsy. The guy offers stickers from 1/10 to 1/24 scale. Again, I'll put the links in the description to everything I'm using here. Okay, so let's go put the panels on. All right, there we go. It is done, and since this is a fast one, let's take it outside to see how it performs. First impression, it's not nearly fast enough. However, I'm afraid to put a faster motor in it because something I only just realized, which I really should have sooner, is the plastic rod ends is a major weak point. for this truck to be anything close to a basher. One broke immediately after I stopped filming. Perhaps metal rod ends exist in this size. We'll have to look into that. It looks like I still need to tune the shocks a bit so they absorb the bumps better. And also you notice it leans to the right under acceleration. I gotta find a way to prop up those shocks in the right rear. Battery life is pretty good. I drove it for a good 45 minutes at high speed, 4 of those minutes with FPV. But that's probably because the ESC doesn't have much of a output. Throughout the video, I've not talked much about the motor and the ESC. The reason is because I'm once again testing out another super cheap brushless setup. And once again, I am not impressed. This motor and ESC combined is about $15. $15 is how much Injora charges for a 050 brushed motor. You know why you don't ever see a brushless motor and ESC combo for $15? Because it's really hard to put together a decent package at that price range. But that's the price point I'm willing to accept for ESC without any tuning, adjustments, FOC, Bluetooth, no bells and whistles. Otherwise, I just get an Injora brushless system for what I think is not that much more. Or I'm perfectly fine with getting a Furatech's starter package, for example. I'm feeling this system I have in the truck right now is just not strong enough. The motor is 1806 size with 12 poles, but I don't think that's the issue. The AM32 based ESC is only a 20 amp unit, half of a Furatech Lizard Pro. Maybe that is why it feels like there is just not enough power when the truck needs to climb over an obstacle from a standstill without any momentum behind it. I'm gonna crimp a JST connector to the motor's wires and run it with a Furatech ESC to verify this theory. The problem is very similar to my last video, the one with the Suzuki Carry K truck. Actually, this one is even worse. I suppose it's due to the gear ratio. With these high-speed overdrive gears, there's not enough reduction, so the torque from the motor doesn't get multiplied enough through the gears. I think that's how it works. Anyway, I just received in the mail some other AM32 ESC, 40 amp boards this time. They are more expensive. $15 for just the ESC without a motor. I'm going to experiment with those and report back. I'm experimenting so much, if I was a female college student, I'd be kissing other girls. As for the FPV system, it is really fun. It's an analog system, so it's inexpensive, but the video resolution is not that great, as you can tell. It's kind of hard to get components that transmit higher quality at this tiny size. Also, I accidentally broke the antenna while I was assembling the truck. I tried to solder it back, but the board and the solder pads are so small, I'm not even sure I soldered it on correctly. Which means the image transmission range was terrible. It became staticky at about 30 to 40 yards. Something I wish I did differently is also have a shut-off switch for the camera servo. I have a separate switch for the camera to turn it off when I don't need FPV, but the camera servo would continue to operate. Yeah, I forgot about that. Anyway, this has been a really fun project. It's a runner, but it obviously is not done yet. I think this is gonna be my last video this year. Have a Merry Christmas, folks, and a Happy New Year, or whatever holidays you celebrate around this time. Thank you for watching. Goodbye.